Alright, here's the probability video. This covers chapters 5 and 6. These are the 5 questions it's going to go over from your test from Tuesday. Just to give you a quick rundown of chapter 5 and 6 again. 5, we started with our probability rules, which the basics are on the formula chart, and we are going to go over some of those in this video. We had just reading two-way tables and Venn diagrams, being able to possibly not have to use these formulas because you're able to get the numbers from here. Also tree diagrams. This is when you had like a sequence of events, like if you don't or do push the snooze button, does that make you late or on time, that kind of thing, where there's a sequence of events. Or the very popular one is someone has a disease or does not, and then the test results are positive or negative. Then we got into the basics of probability models, like all the probabilities have to add up to 1. They all have to be between 0 and 1, the probabilities, stuff like that. And then the more specific probability models, we had binomial and geometric, also normal, but we've talked about that already in chapter 2. So binomial, check the bins, and then geometric, the only difference was there was no fixed number of trials. Okay, so first one we're going to look at is number 4. You might want to have a formula chart handy. I'm just going to breeze through the math of this. Okay, number 4, this is talking about the expected value. Just remember that is on the formula chart. The standard deviation is approximately 1.708. 2 fair 6-sided number, basically 2 die, or dice, land face up, which the following is closest to the standard deviation, again, of the resulting sum. So this is right here, the numbers for just 1 die. Basically, they're saying what happens if we do 2 die, or dice, and we combine the results. So remember, for means, it's just called sum total, T for total. If you were trying to find the total mean, you can take the total of 1 and take the total of 2 and add them together. That was basic, easy. But when you're doing standard deviation, which is what this one asked about, you cannot just take the standard deviation of the first one and add the standard deviation of the second one. Okay, we cannot add standard deviations, but we can add variances, which was just standard deviation squared. So technically that would give us total standard deviation squared. So if we don't want that, we would take the square root of this side. So it was that Pythagorean theorem relationship. So in this case, since it's just 2 die, it's just the same standard deviation happening twice. So 1.708 plus 1.708 squared. Take the square root of that, and if you plug that into your calculator properly, I believe you should get the answer for C. Okay, so that's number 4. That's from chapter 6 when we talked about combining different random variables. Okay, so then this one, police officer estimates that 40% of motorists will be driving more than 5 miles per hour over the speed limit. Assuming the police officer's estimate is correct, what is the probability that among 4 randomly selected motorists, the officer will have at least 1 driving 5 or more over the speed limit? Okay, so the minute you see randomly selected, it's talking about a sample size. So we know for sure we have n equals 4. Your brain should be going back to the probability models, binomial, geometric, normal curves, that kind of thing. So we're going to check the bins. Is it binary? They're either going 5 miles over the speed limit or they're not. Done. Independent. It is safe to assume that each car is independent of it next. Again, that's the kind of more wishy-washy of as long as it is kind of okay, it's fine. Fixed number of trials is the one that makes the difference between binomial and geometric, and they for sure told us that we are randomly selecting 4 motorists. They didn't say something like, what's the probability of it taking 4 people until we get someone that That would be geometric, but we're specifically going to do 4 people no matter what. And then the probability of success, in this case, our success is getting someone driving more than 5 miles over the speed limit, and that was the 40% they told us in the previous part. Okay, so put all that together. What is it asking for? It's asking for, out of those 4 people, what's the probability of at least 1? So probability at least 1 speeding. Okay, think about what at least 1 means. It could be the probability of 1, or the probability of 2, or the probability of 3, or the probability of all 4 of them. Remember, we're going to talk to 4 people total, so only one of them, all the way up to 4 of them could be. The other option is you just do 1 minus the probability of none of them. I kind of recommend doing that way. So if 0.4 is the probability of somebody speeding, 0.6 would be the probability of them not speeding, but we need that to happen for every single one of our 4 people. So we would do that in the calculator. The other option is to try to do binomial, because it's binomial, and then CDF, because it's doing a culmination. The only issue here is that CDF gets very messy when you're having to do backwards problems like this with the at least problems. So I honestly recommend this way better, but if you want to look at that, we can. If you plug it in the calculator, you should get the answer for D. Okay, and we got 12. So it's giving us a bunch of numbers. I'm going to try to write this down as I go. So I'm going to call P for psychology class, F for foreign language. So the probability of someone, or I guess I'll do PS for psychology. So the probability of someone being in a psychology class, they said was 17%. 28% are enrolled in a foreign language, so that's 28. Now read carefully. 32% are enrolled in either, and then it uses the word or. It's very important. So probability of psych or, and remember the symbol for that was union. Foreign language is 32%. Okay, and then what is the probability that a randomly chosen student is in a foreign language and a psychology course? So what we're asked to find is psychology and, remember that is intersection. Okay, if you look at your formula chart, there's a formula that uses all of these options. It's the probability of A or B equals the probability of A plus the probability of B minus the intersection probability of A and B. Okay, now it's giving us this in a slightly different order, but we have all those pieces. So I'm just going to call A psychology, so this is our 0.17. I'm going to call B foreign language. I don't know the and, that's the whole point, that's what we're trying to find. And the or was the 0.32. From there, we should be able to handle that. Combine those and you get, 45. At any point, you could always use the choices and plug them in and see which one works. So basically, 0.45 minus what? We give you 0.43. Well, okay. But just setting it up, using your formula, really watch out for those ors and those ands. Okay, number 19. 2 college roommates have committed to donating to a charity each week. They are independent of each other. That's important. That just means we can multiply them together if we're trying to find an and. Approximately, I'm so sorry. Approximately normal, this is for one roommate with a mean of 30 and a standard deviation of 10. And then the other roommate, also approximately normal, mean of 60, standard deviation, which that's spelled wrong, whoops, standard deviation of 20. Closest to the expected number, which remember is just a fancy word for mean, of the 52-week year. So we're going to have to combine this together 52 times for which the following is the closest expected number will exceed $120. Okay, so this one's got a lot going on. Let me make sure I'm getting the right calculator stuff going. Okay, this is kind of combining what we talked about a second ago. We need to do our combination. So again, I'm going to call T the total of all 52. No, this is just the total for 1 week. On any given week. So the average total. So the average from one roommate is 30. The average from the other roommate is 60. So the average from just 1 week total is 90. Same thing for standard deviation, but remember, instead of doing, it was 10 and 20, so 10 and 20. Remember, we square them, take the square root. And I already did this in my calculator, and I got 22.36. So again, this is just from 1 week. So then we have to look at the probability of this 1 week exceeding 120. So picture They told us that each of those was approximately normal, so all of this is still approximately normal. But now we have the new mean and the new standard deviation and all that. And it's asking us if the donation will exceed $120. So 120 is over here somewhere, and we're finding this area. Again, this is all just for any given week. Okay, so then this is just normal CDF. So normal CDF, lower bound is 120, upper bound, big number, mean, and standard deviation. So you had to find those numbers to be able to do this. So if you do this, this should happen. They should have any given week exceeding $120 should happen. I believe I got 0.09, about 9% of the time. So then it's asking, what is the expected number out of a 52-week year? So it should happen every week with a 9% chance. So basically 9% of these 52 weeks, we would expect this whole scenario to happen. So we're basically finding 9% of 52. So 0.09 times 52, and you should get 4.67, which, you know, round 5. Okay, so that was probably the trickiest one of all these 5. And last but not least, number 20. This is also a little bit of a tricky one. This is one of those ones where I would recommend don't try to do fancy formulas. Make sure you understand what's happening. So we've got 2 different cubes, basically die from 1 to 6 being rolled. So here's die 1. Those are all the options of what could get rolled. I went over an example like this a while back from your mock, and I honestly recommend doing this on problems where it has to do with dice and all these options. Like if it's a set number like this, just 1 to 6, it's not like from 1 to 100, this is doable, right? If it's going from like crazy big numbers, like you have so many options, this becomes less realistic. But if it's just 1 to 6, like this is not that crazy. Then we got another die, doing the same thing. Okay, and then we were looking at the sum of the 2 faces shown. So we got 2, 3, 4. Feel free to skip to when I'm done. Going as fast as I can. So, and this gets into craps, the game of craps a little bit, but 7 is the most likely sum that can happen. Okay, so here's all the options. So if I read through the problem, it says the sum of the numbers appearing on the faces landing up are recorded. What is the probability that the sum will be 4? So I'm going to write this down. What's the probability that the sum will be equals 4 given, that is a big flashing red line, conditional, that the sum, so given the sum is less than or equal to 6. Now you can try to do this with a formula, and I'll go ahead and stick with that. So the formula, if you check what the conditional formula is on the formula chart, it is the and over the given. So this, we'll be finding the sum equal to 4 and less than or equal to -6, and then over the probability of the given, which was the sum. Now this is going to be a little bit redundant. There's a way to skip it, but I'll just stick with this. So let's just do the given part first. What is the probability that the sum will be less than or equal to less than or equal to 6? Well, if I look at all these options, that encompasses all of these options, right? All of those over here. So there's a total of 36, and then the ones that are going to give us this sum, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 different ways we can get a sum of 6 or less. Okay, on top it's saying the probability is equal to, the sum is equal to 4, and that's happening. So again, we're still ignoring all those numbers, and then so all of this has to be true, and the sum has to be 4. Well, that's just those 3. So it's 3 out of 36 that happens. And basically, the 36s are going to cancel each other out, so it ends up being 3 out of 15. So you could have just said, okay, well, given that this was true, the sum had to be 4. That's 3 out of that 15. Either way, you end up here. And that's the answer for C. All right, grab your practice worksheet. I believe it will be in green.